Have you ever been in a situation where you have to solve some sort of equation, but you have no idea how to get x alone? For example, over here, maybe you're not so sure how logs work and you need to get the value of x. How the hell do you do that? Maybe you're not sure how to get exponents, how to get your variable out of an exponent, and x is over here. How the hell do you do that? Well, until you learn that tool, you might find that the one I'm about to show you is much faster, much quicker. All right. The one that I'm about to show you is quite simply learning how to use, well, calc intersect. All right. So let me show you a simple example up here up top with 3x equals 9. And later on, we're going to see how it works with the other two. All right. But I really need you to understand what is going on behind the scenes. All right. So here for 3x equals 9, let's first solve it by hand, and then I will show you the trick of calc intersect. Again, this only works if you have a graphing calculator in your hand. So 3x equals 9, right? How do you get x alone? Well, x is being multiplied by 3, so you're going to divide by 3 because it's the opposite, ¿cierto? This goes away with this. Got to do it to both sides. X equals 3. All right, how can I get that x equals 3? It's through calc intersect. Well, when you're working with calc intersect, the idea is the following. You will take each of these sides and graph it. Each of the sides. So you're going to say that this, for example, is y1. And when I say y1, I mean pressing y equals on your graphing calculator and this y1 up top. So that's going to be y1, 3x. And your y2, you probably guessed it, is going to be 9. So what you're doing here is that you're graphing both sides, checking where they intersect, and wherever they intersect is going to be your answer. See, so I'm going to show you how we get to x equals 3 through calc intersect. So if I go ahead and graph this, I'm going to go ahead and change my window immediately. If I go ahead and graph it, it looks something like that. All right, cool. So here I can see both of my lines, and I can see that there's a single intersection up there. So if I go ahead and do calc by pressing second trace, calc and then intersect, hence the trick, hence the tool, I see that it asks for three things. First, it asks for what is your first curve. So I go to the left, I go to the right. All right, clearly my first curve is just the line that is going diagonal, and my second curve is the one that is horizontal. See? So I press the second curve, and now I have guess. All right, so guess, your calculator knows where the intersect is. Okay, your calculator is super smart. But the guess is basically you asking it like, I want the answer on this intersection. All right, when you're working with parabolas and other functions, this can get relevant. For our examples, it will not be. You do calc intersect, you get that the intersection is at x equals 3 and y equals 9. So, what the hell? So it tells you that, I'm just going to go ahead and grab this for a sec. So I have something that goes like this, something that goes like that, see? And I find that this point up here is 3 comma 9. That means that over here I have 3 and over here I have 9. All right, where did those numbers come from? This 9 here is that 9 there. And this 3 here is the value you got for x equals 3 doing it by hand. See? And so the key idea is that when you do the y1, y2 thing, okay, one of them is going to be a horizontal line. In this case, my horizontal line was going to be 9, okay, which is one side of my equal sign. And that is all you need to know for the calc intersect trick. Now I need you guys to believe me that this works for weird stuff. See, so imagine we're facing the log problem over here. You have no idea how logs works. Maybe whatever, man. You're studying for the AB, for the ACT, or whatever. You have the graphing calculator, and dude, you forgot the log part. There's this one log problem. You don't know how to solve it, but you do know how the calc intersect trick works. So what would you do? Well, first of all, you would say that the left side, and again, this is arbitrary, but I guess, whatever, man. You say that this is y1, you say that this is y2. So let's go ahead and graph that. So here I have log 3x for y1, and y2 is going to be 2. So I go ahead, do zoom, fit, see what I end up with. All right, so here I can see my two lines, but they are not intersecting. And since I want to use calc intersect, I need to see the intersection. So let's play around with the window a little bit. Again, the graph doesn't have to look nice, but you do have to be able to see the intersections. So I'm just going to change it to, I don't know, blah, blah, blah. Let's see what happens. So my maximum is now 5 on my y. Boom. There I'm starting to see an intersection. See? Now just to make it very, very clear and to have a more nice graph as well, I'm going to go ahead and do this. All right, so now it's evident that there's this intersection going on over there. See? So again, I don't know how logs work, but I know how the calc intersect trick works. So I can go second calc, and I hit intersect. Pick my first curve, pick my second curve, do the guess thing. Boom. I end up with the following point. I end up with 333.333, comma, 2. Now, I did mention earlier, okay, in the calc intersect trick, either y1 or y2 is like one of the values you're going to get at your sets of points. See? So this 2 is this 2 that's here. And this y1, in effect, is going, and this 33.33333 has to come from my y1, and it has to be x. So x in this case will equal 33.333. All right, awesome. And now over here, we can see the last example. See? Again, your variable is on an exponent. The thing looks super weird. You have no idea how to get it down from there, see? And even if you did, it takes a whole lot of steps. See, anyone that knows how to solve this knows that it takes a couple steps, see? And so you might find that it's faster if you go ahead and just graph it, see? So we're going to say that y1 is going to be 5,000. And this whole thing on the right, no matter how nasty it is going to be my y2. So as long as you trust the process, no matter how nasty it looks, you're going to get there. So y1 is 5,000, y2 is going to be 300 times the thing that's inside. So 1 plus the fraction of 2 over 100, close parentheses, to the power of 5x. So again, this looks nasty. We're graphing something that looks nasty, but trusting the process, we're going to get there. So I go ahead and graph. All right, clearly it doesn't show up. See, so we have to play around with our window a little bit. So I press window. Well, actually, I'm going to go zoom fit. Zoom fit sometimes gives you the intersect. Most of the times, it gives you a good place to start. So if I press zoom fit, it changes the window for me. And it looks something like that. So I can see that my second line does intersect with the first one. And even though the graph looks nasty, I can find the intersect. So calc intersect, first curve, second curve, guess. Boom, I end up with that value. So it gives me that this point here is where it intersects. 28.41452, comma 5,000. So again, for interpreting this, the key thing, as you've seen in the other examples, is which of these is my y1, which of these is my y2. So this 5,000 comes from my y1, because there's a 5,000 over here, and this 28.414 comes from my y2. See? And if it comes from my y2, that means it is my value for x. So x in this case, even though I didn't have to do anything else, is going to be 28.41452. That is the calc intersect trick, and at the end of the day, you can use it any place, anytime. You do not need to know how log works. You do not need to know how to get that exponent down from, that variable down from the exponent, but you do need to know how calc intersect works. So again, this can be applied in so many contexts. It's a tool that's helped me countless times, and I thought I would share it with you. So take it easy. I hope it helped.